Hi there, everyone. Because class was canceled today, I decided just to record a video in lieu of today's lecture and just talk a little bit about the material that we would have covered in class today. Here's what I'm going to do. I'm not going to spend really time on the PowerPoints, but let me share my screen here. This is the class homepage that you're all familiar with. So here's what I'd like you to do. You can obviously review the PowerPoints on your own. They're here. But I think most important, what I'd like you to do is make sure you watch these videos. Okay, I think you'll find these very helpful in doing the homework and just understanding some of the concepts. So I'm going to ask you to, there's always videos associated with each section, but since today's lecture was canceled, I'm especially encouraging you to make sure that you watch these. What I'm going to do is I'm just going to spend some time going over some problems from the section 13.4 in the textbook. And what I want to do is I want to do some problems that are similar to the ones that you'll be encountering when you do your own homework, okay? So I'm going to go through these and then if you have any questions, then you are always welcome to email me, reach out if anything isn't making sense. But I'm hoping that this combined with the other videos will get you to where you need to be to do the homework and the quiz for this week. So, okay, I'm going to start with just a few kind of basic probability problems here. So, I'm going to start with problem 5 actually. And you see that we are given 3 probabilities: P of A equals 1/2, P of B equals 1/3, P of C equals 1/6. Okay. And I'm going to do actually 5, 8, 11, and 12. Okay. All 4 of those problems refer to the same probabilities. I'm going to kind of go back and forth a little bit. I'm going to bring up a whiteboard right now, and then we'll kind of have to jump back and forth. It's just no other way to do it with this. So I'm starting with problem 5. Okay. And I was given these probabilities. I was given P of A equals 1/2, P of B equals 1/3, and P of C equals 1/6. Okay. For problem 5, I was asked to find the probability of the complement of A, which according to the rule of complements, this is just equal to 1 minus the probability of A. Okay. And this is equal to 1, oopsies. Sorry, let me erase that a little bit here. There we go. All right. 1 minus 1/2, okay, which equals 2/2 minus 1/2, which equals 1/2. Okay, so that's pretty straightforward. In problem 8, what we are asked to find is the probability of A union B. Okay. Again, I'm going to be using some formulas that will be kind of developed when you watch those other videos. So like, I would encourage you to go watch the video for that describes the probability of a union and probability of an intersection. And then also the concept of independent events is pretty important, and there's a video about that. However, what you'll find in that other video about probability of a union, that the formula for finding the probability of a union looks like this. the probability of A union B is equal to the probability of A plus the probability of B minus the probability of the intersection of A and B. Okay. This can be further simplified in the following way. The probability of A intersection B can be written as just the product of P of A times P of B. The reason for that is because the problem specifically tells us that events A and B are independent. And independent just means that the occurrence of one event does not have any influence over whether the other event occurs or doesn't occur. Okay. Again, that idea is fleshed out more if you look over the PowerPoints in that video on independent events. But it turns out that if events are independent, then the probability of the intersection of those events is just equal to the product of the individual probabilities. Okay. So this ends up equaling P of A is 1/2, P of B is 1/3, and P of A times P of B is, let's see, 1/2 times 1/3. Okay, so then we simplify this down. This equals 1/2 plus 1/3 minus 1/6. Okay. And this equals 3/6 plus 2/6 minus 1/6, finding a common denominator on all the fractions. 3 plus 2 is 5, 5 minus 1 is 4, so this equals 4/6, which reduces down to 2/3. Okay, so that is the probability of the union of A and B. Coming down here, let's take a look at number 11, which says this. Probability of the union of A and B intersected with C. Okay. And actually, we've already found the probability of the union of A and B up here in problem 8, right? We found that to be 2/3. And remember, for independent events, which these are, you can just multiply. The intersection basically means multiply, right? So we're taking the probability of the union of A and B, which is 2/3, and multiplying it by the probability of C, which is 1/6. So that just becomes 2/3 times 1/6, or 2/18 or 1/9. Okay. All right, and then finally one more. I'm going to, this is problem 12, probability of it says we've got the intersection of A, B, and C, but then the complement of that. Okay, that's what we're asked to find. Now, according to the rule of complements, this is equal to 1 minus just the intersection, right? And because they're independent events, I can just multiply. So I've got 1 minus P of A times P of B times P of C, which equals 1 minus 1/2 times 1/3 times 1/6, which equals 1 minus 1/36, or that ends up being 35 out of 36. Okay, so you'll see a few problems similar to these on your homework, and you can all work those out in similar ways as what I did here. So, let's go back over to, my textbook here. And now I want to move on to look at a problem involving, some problems involving a tree diagram. So we're going to move on down here, and we've got this tree diagram, and I want to go over problems 25, 26, 29, and 30, which all relate to this diagram, okay? 25 and 26, just to figure this out, you just have to look at the diagram, right? So it says which path number represents the probability of D given A2, right? So it's saying that's what the vertical line there represents conditional probability, which we talked about in class last time. So what is the probability that event D occurs given that event A2 has already occurred, right? So these are your conditions, the first set of branches, right? So we're saying that A2 has occurred. What's the probability that D occurs? That's going to be this branch here, right? The branch labeled D corresponding to A2, right? So it says which path number represents that? Well, it's going to be the second branch of path 3, right? This is path 3, the second branch of that. So it looks like that probability would be 0.5, but it just says which path number, right? It would be path 3. Similarly, probability of the complement of D given A3, right? Here's A3, so that's given. And what's the probability of the complement of D? That would be right here, right? It would be the second branch of path 6 is what that probability represents. Okay, then we come down here, find the probability of D given A1 times the probability of A1, okay? So the probability of D given A1, well, here's A1 and here's D, right? So that probability is 0.6. And the probability of A1 just by itself is 1/2. It's over here, okay? So come over here to a whiteboard. I'm going to clear this. So I've got, we're on 29. Okay. Probability of D given A1 times probability of A1. Okay. So for D given A1, you find the A1 branch, and then you find the D branch coming off of the A1 branch. And the probability you'll see there is 0.6. And then for probability of A1, you just look at the branch labeled A1 and look at the probability corresponding to that, which is 1/2. So this is equal to 6/10 times 1/2, or 6/20 or 3/10, or you could write that as a decimal as 0.3 if you want to. Okay. Okay. And then for 30, it says find the probability of the intersection of A2 and D. So when you see an intersection, you could also just replace that with the word and, saying what's the probability of A2 and D1? And for an intersection, the mathematical operation there is also a multiplication, right? So the probability of A2 is 1/4, right? And the probability of D corresponding to A2 is 0.5. So because it's an intersection, we multiply those together. So it's going to be 1/4 times 0.5, or 1/4 times 1/2 is what you're looking at. Okay. So 30. Okay. Got the probability of A2 intersection D is equal to the probability of A2 times the probability of D, which is equal to 1/4 times 1/2, or 1/8. Okay. All right. So There's two other problems I'd like to go over before we finish up for today. The next one I want to look at here is 38. Suppose a slot machine has 3 independent wheels as shown in figure 1310. Find the probabilities. So independent just means that you spin one wheel and it'll land on something, right? Then you spin the second one, it'll land on something. You spin the third one, it will land on something, but they're independent. So whatever you get on the first wheel is not going to have any influence on what you get on the second or the third, okay? They're considered independent events. So you'll have some similar problems on your homework. So we want to answer a series of questions. So each wheel has 20 slots, and the slots correspond to, I guess, different fruits. Maybe it says there's bell. Maybe that one's not a fruit, but maybe a bell pepper. And some other objects. Anyway, so like the first one says, well, let's find the probability of 3 bars, right? So for that, you have to find the probability of getting a bar on the first wheel, getting a bar on the second wheel, and getting a bar on the third wheel. And then the probability of 3 bars is basically the intersection, right, of all 3, and they're independent events. So you just multiply those probabilities together, okay? So like on the first wheel, if you count, there are 1, 2 bars, okay? So the probability of getting a bar on the first wheel would be 2 out of 20, right? Because there's 2 bars out of 20 options, 20 possible outcomes, okay? And for the second wheel, you count the bars, 1, 2, 3, 4 bars. So the probability of getting a bar on the second wheel is 4 out of 20, right? And then on the third wheel, I see 1, 2 bars. So the probability of getting a bar on the third wheel is 2 out of 20. And I multiply those together. So let me go over to a whiteboard here. Okay. This is problem 38. The probability of 3 bars. Well, this is equal to the probability of getting a bar on the first wheel, which we said was 2/20, times the probability of getting a bar on the second wheel, which was 4/20, times the probability of getting a bar on the third wheel, which is 2/20. If I reduce these fractions, I get 1/10 times 1/5 times 1/10. Or when I multiply, I get 1 out of 500. So the probability of getting a bar on all 3 wheels is 1 out of 500. Back over here. Second question, what's the probability of getting 3 bells? Okay. Well, again, do a similar thing, right? But this time we're looking at bells. So on the first wheel, I see only 1 bell. So that would be a probability of 1/20. On the second wheel, I see 1, 2, 3, 4, 5, 6 bells. So that would be a probability of 6/20. On the third wheel, I see just 1 bell. So that would also be a probability of 1/20. And then I multiply those 3 probabilities together to find the probability of getting a bell on all 3 wheels. So that looks like this. Probability of 3 bells equals 1/20 times 6/20 times 1/20, or 6 out of 8,000, or 3 out of 4,000. Okay. All right. All right, for part C, probability of 3 cherries, right? So same thing, but this time we're looking at cherries. I see 1, 2 cherries on the first wheel. I see 1, 2, 3, 4, 5 cherries on the second wheel. I see 1, 2, 3, 4, 5, 6, 7, 8 cherries on the third wheel. So when I multiply the probabilities, I'm going to get this probability of 3 cherries. 2/20ths is the probability for the first wheel. 5/20ths is the probability for the second wheel. 8/20ths is the probability for the third wheel. This equals 80 out of 8,000, or 1 out of 100. Okay. And then D, it says, what's the probability of getting cherries on the first wheel? So with this, because they're independent, it doesn't matter what happens with the second or third wheel, just what happens with the first wheel, right? So we can ignore the second 2 wheels. And on the first wheel, we see that there are 2 slots labeled cherry out of 20 slots total. So probabilities of cherries on the first wheel is just 2 out of 20, or 1/10. And then E, cherries on the first 2 wheels, right? So with this, we can just ignore wheel 3, and we find the probability of cherries on the first wheel, which was 1/10, and multiply that by the probability of cherries on the second wheel, which is 5/20th. And that ends up being, when you multiply those, you get 1/40th. All right. One more problem we're going to go over here. It's problem 47, where we explore the concept of selecting an item with and without replacement. Okay. So assume a jar has 5 red marbles and 3 black marbles. Draw out 2 marbles with and without replacement. So with replacement means you select the item and you put it back before you select another item. Without replacement means you select an item, in this case a marble, and you don't replace it. You set it aside somewhere before you select the second marble. Okay. So we would just want to go over these questions. Let's start with part A. What's the probability of selecting 2 red marbles? And there's going to be 2 answers here. We want to look at what would the answer be if it's with replacement, and what would the answer be if it's without replacement? Because you're going to get a different answer either way. So let's take a look. This is 47. So just to be clear, I've got 5 red marbles, right? Three black marbles. Which makes 8 total. Okay. So for A, what's the probability of getting 2 red marbles? Probability of 2 red. Okay. So let's look at what it would be with replacement first. So we would say, this would basically be, what's the probability of getting red on the first and red on the second, right? Well, there's 5 red marbles and there's 8 total. So red on the first would be 5 out of 8. And if we replace it, the second time we go to select a marble, there will still be 5 red marbles and 8 total, right? So the second probability is also 5 out of 8. This is equal to 25 out of 64. This is with replacement. But if it's without replacement, it would be a little different. The first one would still be 5 out of 8, because when we go to select the first marble, there are 5 red out of 8 total. But if we don't replace it, and if we assume a red was selected first and we go to select another marble, there will only be 4 red ones left and 7 total, right? Because we didn't replace it the first time. So this is equal to 20 out of 56, which equals, it reduces down to 5 out of 14. Okay. All right. Part B is pretty similar. It's just find the probability of 2 black, and you do it the same way basically as this one, right? Except we're looking at black instead. So I want to move on to part C because part C is a little trickier. Just flip back over here too. Okay. Part C, it says, what's the probability of getting 1 red and 1 black marble? Okay. So if we're looking at the probability of 1 red and 1 black, there's actually 2 ways that could happen. You could get red on the first draw and black on the second, or you could get black on the first and red on the second, right? So when we're trying to just find the overall probability of 1 red and 1 black, we have to factor in both of those orders, right? So what we're going to do is we're going to start by finding the probability of getting red on the first draw and black on the second draw. Okay. Well, and we're going to do this both with and without replacement. Okay, so first with replacement. Well, with replacement, that means the probability of red on the first is 5/8. And if we replace it, then when we go to pick the second one, there's going to be 3 black and 8 total, right? So this ends up equaling 15 out of 64. And I want to label, I forgot to label this. This is with, this is without. Okay. And similarly, this is with replacement. And then if I calculate it again without, well, the probability of red on first is still 5/8. But if I don't replace it, and I go to pick the second one, there's still going to be 3 black marbles, but only 7 marbles total, right? So this equals 15 out of 64, and this is without. Okay. Now, the other possibility is that we get probability of black on first and red on second. So let's calculate both of these, both with and without replacement. So with replacement, probability of getting a black first would be 3 black marbles out of 8 total, right? And if I replace it and then go to pick a second one, the probability would be of getting a red one would be 5 out of 8, right? Because both times we're selecting from 8 marbles. And this equals 15 out of 64. This is with replacement. Without replacement, the probability of getting black on the first would be 3/8. And if I don't replace it, there's only 7 marbles left when I go to pick the second one, right? So the probability of getting a red one would be 5 out of 7, or 15 out of 56. Okay. I just realized I made a mistake. I apologize. You might be confused because of that, but my mistake is this is not 15 out of 64. This is 15 out of 56. Okay. So let me fix that. Shoot. There we go. Oh, it's a lousy 5. All right. All right, that's better. This is without. So the overall probability of getting 1 red and 1 black is going to be this probability or this, right? It's basically going to be the union. And so you can just add those together. Okay, so if we do it with replacement, it would be Just add those together. So 15 out of 64 plus 15 out of 64 equals 30 out of 64, which equals 15 out of 32. This is with replacement. Okay. Or without replacement, it would be 15 out of 56 plus 15 out of 56, which equals 30 out of 56. Or that reduces down to 15 out of 28. This is without. Okay. Yeah, so that is, I'm going to stop here. This is, mostly just wanting to go over some problems similar to the ones you'll encounter, but please review the PowerPoint and the other videos as well. And if you have any questions, reach out to me. Thank you very much, and we'll see you all next week.